So then my equation should be y minus 2 is equal to 8 times x plus 4. So any questions on writing the equation of a tangent line? So really it's nothing new than what we did before. Okay? Questions on that? All right. Not only do you have to be able to find the derivative algebraically, like I said, you always have those different representations. Algebraic, graphically. So we know now how to find the derivative algebraically by doing the limit as h approaches 0 of f of x plus h minus f of x all over e. You also have to be able to find the derivative graphically. So instead of me giving you a function, an equation, I'm giving you the graph of f of x. So you now have to be able to find the derivative graphically. All right? So to find the derivative graphically, here's some hints. To get started, to find your graph, you want to find any horizontal tangent lines. This is how you get started in terms of finding the derivative graphically. Find horizontal tangent lines. So let's take a look at A. Do you see any places where you'd have horizontal tangent lines? X equals, let's work left to right. Negative 3, about, Jack said I think negative 1/2 right here, about 2, and about 4. So if you make a table of values, because you can graph any function by making a table of values, and that's exactly what I'm going to do here. So remember, what is the derivative? What is f prime? It's the slope of the tangent line at a particular x value. So my first, and again, I'm going to build my table going from left to right. So you told me, first of all, the first horizontal tangent line is occurring at negative 3. So at negative 3, I left a space above negative 3 for a reason. What is the slope of the tangent line at negative 3? 0. You have found one point on the graph of the derivative. So we all should know how to plot the point negative 3, 0. Now this is where last class I told you guys to get over the whole exact value, and we talked about the estimations. So now let's talk about what's happening to the left of negative 3. Let's talk about all the values of the derivative less than negative 3. So what can you tell me about all these slopes from negative 5 to negative 3? These are all what? Positive. So you agree with me that no matter what, when I find these y values, the y values will be positive, because every single slope of the tangent line here is going to be positive. So graphically, what happens? Well, what happens with positive y values? Where is this graph of the derivative going to be located? Is it going to be located above the x-axis or below the x-axis? Above. Because remember, this is where f prime of x is greater than 0. F prime of x is greater than 0 when all your y values are above the x-axis. That's where all your y values are positive. If f prime of x happens to be less than 0, the graph is going to fall below the x-axis. Does that make sense to everybody? Okay? Yes? So if you have a positive slope, remember, you're finding the slope of the tangent line. So again, you're sketching a derivative. So if it's a positive tangent line, that means the value is greater than 0. So when I get to plot these points, it's got to be above the x-axis, because that's where the y values are positive. On the graph of the derivative, the y values are the value of the slopes of your tangent line. Okay? Now, so this is my recommendation. In your interval, so again, from negative 5 to negative 3, an estimation. Where is the slope the steepest? Only need to find about one good point in each interval. So where approximately is that slope going to be the steepest? Well, we're between negative 5 and negative 3.
Oh, okay.
So maybe about negative 4, maybe like right about here. So what you did last night, so maybe right about negative 4. So approximately at negative 4, what would be a good estimation for the slope of this tangent line? 1. So again, we estimated from negative 5 to negative 4. Again, if you think this is the steepest place, this has to be the largest point, doesn't it? This has to be the largest point. So what that means is this is going to have the largest y value. So all the other y values from negative 5 to negative 3 should be below negative 1. Okay? Again, it's an approximation. All right? Again, this is probably all pretty close to 1. I probably shouldn't have curved this down. This should probably be more like this. Probably closer to 1. But again, as these values are getting closer and closer to our horizontal tangent line, these values are getting closer to 0. Again, we are going to have variations. We are going to have, these are estimations. Get over the fact that these are going to be exact. But we're all going to, one thing will be true. This graph has got to be above the x-axis from negative 5 to negative 3. Some of you may have said this slope, the steepest part of this slope was 2. So that means the highest point would be 2. So what you want to do in each interval is find the highest or the lowest point on the graph of the derivative. All right? So again, let's now take a look. Again, you told me we have another horizontal tangent line, maybe about negative 0.250. So here's another x-intercept on the graph of the derivative. Now, what can you tell me about the slope of my tangent lines from negative 3 to negative 0.25? They're all what? Negative. So graphically, what's going to happen with the graph of the derivative? The graph of the derivative is going to be, in that interval, is it going to be above or below the x-axis? Below, because all the slopes are negative. So right here, these are all negative. So where does it appear we have about the steepest slope? About negative 2. So at about negative 2, what is a good approximation for this particular slope? Negative 1 or negative 2. I'm going to say negative 2. So then at negative 2, I have a y value of negative 2. You said negative 1.5, then you'd put your point at negative 1.5. But if that's where it appears to be the steepest, all of us should have a point around this area somewhere. That should be the lowest point in this particular interval from negative 3 to negative 0.25. Okay. Next, you told me that we have a horizontal tangent line at 2. So at x equals 2, we have a slope of 0, which means I have another point on the x-axis on the graph of the derivative. So what's happening with all of the tangent lines between negative 0.25 and 2? These are all what? Positive. So what does that tell you about the graph of the derivative between negative 0.25 and 2? It's going to be what? It's going to be above. So now, look in this interval. Where does it appear the steepest slope is going to be? It's going to be about what? About 1? Or maybe 0.5 right in here, I would say. Now, compare, this is what you had practiced doing last class. This is why we did that exercise. Compare the tangent line that we sketched in that first interval to what we just did. Which slope appears to be steeper? The second one. So what does that tell you in relationship to the point I plotted here? This point should be higher. So what's a good approximation for this slope about? I guess that's probably about maybe 0.75. What's a good approximation for this particular slope here? Maybe about what? 2 or 3. Let's just do 3. Let's make it a little bit bigger so we can exaggerate this a little. So at x equals 0.75, I'll have a y value of 3. Or maybe 2.5 will probably be better. Okay. So the big thing is, what I'll be looking at is not necessarily the value that you chose, but obviously the slope of this tangent line is steeper than this one. So when I'm checking your diagrams, what I'll be looking for is that this point is higher than this point. Not necessarily the number, but again, it's the comparison you're making between the slope of the tangent lines. Does that make sense to everybody? I'll be checking that you have the x-intercepts in the correct place. I'll be checking that your derivative is above or below the x-axis in the correct place, as well as the comparison of the steepnesses. In other words, this point should be higher than that first one. Does that make sense to everybody? Okay. Then finally, you told me we have another horizontal tangent line at 4. So that tells me I have a slope of 0. So now, what can you tell me about the slope of the tangent lines between 2 and 4? Are they positive or negative? Negative. So what does that tell you about the graph of the derivative? The graph of the derivative between 2 and 4 is going to be what? Above or below the x-axis? It's going to be below, because that's where the y values are negative. So all of this, I have negative slopes. So where does it appear the slope is the steepest in this interval? It appears that the slope is the steepest where? At about 3. So compared to the slope that we chose for between that interval -3 to -0.25, which slope appears to be steeper, the one we just did or the previous one? New one. So remember, we said approximately at that this had a y value of about -2. So it would be a good approximation for the steepness of this slope. It's going to be what? -4. So then at 3, -4. Again, notice you want to assure that this point is lower than this one, which indicates that this had a steeper slope in there. Okay? And then finally, you told me from 4 to 5. These slopes are all what? These slopes are positive. So again, it appears to be the steepest right about here. So compared to the previous positive slope of the tangent lines, does this appear to be the steepest? Yes. So again, what does that tell you about 5? Thank you. At x equals 5, we should have a slope, make sure it's higher than this point, so it's probably, what would be a good approximation? At 5, we should probably be at what about? 4. 3 or 4. Depends upon what you call that other one. Okay? So again, let me just highlight some things for you. On your original curve f of x, if you have a positive slope, the graph of the derivative is above the x-axis. Yes, Emma? Yeah, let me finish this and I'll get it for you. If you have the interval where it's f of x is decreasing, you have negative slopes. Notice the graph of the derivative is falling below the x-axis. Where it's increasing, it's above the x-axis. Where it's decreasing, the value of the derivative is below the x-axis. And then finally, where it's increasing, the graph of the derivative is above the x-axis. Okay? And that's what I was trying to emphasize the other day. It's not about the exact value of the slope. You're doing estimations. The key is finding approximately where the slopes are the steepest, so you know on the graph of the derivative where to put the highest or the lowest point. Okay? So any questions on the first one? Yes, Tim?
I was just wondering why the line at x equals 1 is less than x equals 3. It looks like 1 is slightly steeper.
You mean here is steeper?
Yeah.
Then what?
3.
Well, this is a negative slope. Because this slope is negative, this one's positive. So that's why this one has to be above the x-axis, this one is below.
So does it matter if the y is greater than or?
You mean you're saying that this should be like maybe -2?
Yeah.
Okay, that's fine. Like I said, I'm just checking in comparison to the negative slopes. Again, these are estimations. These are estimations. It's really, again, it's really a comparison to where you started with that first positive slope, and you're comparing all the positive slopes versus all the negative slopes. And again, that's where the variations would come in. But no matter what, when I'm looking at your graphs, I should see that at x equals 3, this should be the lowest point on everybody's graph, regardless of where it is. Does that make sense? And then on all of our graphs, this should be the highest point. And then this one, and then this one. That's why the exercise was critical to practice, like putting those numbers in order from smallest to largest last class. Okay? Any other questions? All right, let's look at another one. First of all, on your own right now, identify horizontal tangent lines for me. So identify the horizontal tangent lines for me here.